Joining us today to provide guidance on feasibility is Mr. Kosala Jayasundara. Mr. Jayasundara is the founding director of ExcelTech, a medical electronic device manufacturing company based in Estonia. He currently works as a faculty board member at the Faculty of Engineering of University of Sri Jayawardhanapura and is an esteemed alumni of the Department of Electronics and Telecommunication Engineering of University of Moratuwa. Sir, we are extremely grateful to have you with us today. We trust that your expertise will provide guidance to determine the feasibility of our participants' innovative concepts in the field of medical technology. If you have any questions regarding the topics discussed in the workshop today, please feel free to submit through provided in the chat or simply type them in the Zoom chat. Your questions will be answered in the Q&A session. Now, without further ado, join me in welcoming our esteemed speaker tonight, Mr. Kosala Jayasundara. Over to you, sir.
Hi, good evening, everybody. It's a great honor to talk to you about the product development, especially in the medical field. And I'm hoping that the hour that we are spending together is useful and you can learn something out of it. So let me introduce a little bit about myself. What I'm doing in the recent years. So myself, I graduated from University of Moratuwa in 2004, started a few companies in automation, product development, electronics from 2004 itself. And I worked in MS innovation for some time, around 6 years, and analyzed deeply about product development. We developed products with most of the US companies, stayed there sometimes. So I got a good understanding about medical and wearable product development there also. In my current company, ExcelTech, which is now registered in Estonia, but now I have a Sri Lankan company and Estonian company working together. And we started in 2020, and we mainly engage in FDA Class 1 and Class 2 level product development. My current business model, part of it is in contract product development, where I'm not going for initial conceptual research, but I'm getting a product inquiry from a customer and develop it for their demand. That's the first part of my business. And recently I started the second part of the business, where I'm actually working on developing my own medical product. And I'm focusing on FDA Class 2 therapeutical product on this development. And you can see the boards and everything I developed in medical domain, which are all FDA Class 1 or 2 certified. So that's what I normally do. So I think I can give you at least some useful information about this journey in electronic product development for medical space. So we have a few success stories. I just don't want to go in detail, but some are in medical therapeutic device, first and second. Third one is again a microprocessor-based monitoring device for ECG, EMG likewise, which need very high power and data rate. So it's kind of microprocessor board. Fourth one is again a therapeutic device in medical heating. All these devices are FDA Class 2 certified, either they are certified or being in the certification process. And in the right left, I am doing a few other projects that I can't share the images. In one case, it's either IP protected or we have not applied for the customer has not applied for the patent yet for these products. But I'm working on fetal monitoring, SpO2 monitoring, hospital patient continuous monitoring of ECG and blood pressure, temperature likewise, and also some projects in pain relief. So these are my expertise, what I have done and what I'm continuing to do. And in this short lecture, I wanted to focus a bit on what it takes to make a product or idea into an actual product that consumers can use. It's a long journey, and I would like to shed light on as much as possible on these different steps in the journey. Only a small part of it is the actual product idea. So if I can explain you it in a bit detail in this slide, when we get an idea, say I'm hoping that in your current state, you are getting an idea and converting that to product, right? Like in some companies, like bigger companies like Philips, Honeywell, where they are working on their own portfolio of products, this is not the way they are doing. They are first looking at the space and finding out gaps, and then looking actively for a viable products to match that gap. That's the way that they are normally looking at. But I'm assuming at your stage, you are starting with an idea, whether it is a problem that you have in hospitals or in your university or what your lecturer has discussed or your personal experience, and then looking forward into pushing it to market. So in that journey, we are starting with idea or problem that you have. And initially you do a market analysis and biomedical analysis to see whether it's actually viable, like in very basic layman terms, whether we can actually do it or it's totally unrealistic. Then we have to write a proper product description, see what's out there in the market, do a complex market research, which might take months sometimes, and then see whether that's viable as a business. And then we can see whether it is viable as an engineering product development. It might be like concept is really good, but the circuitry, complexity, battery size might not match the current requirement. And then if everything is okay, you can go for proof of concept prototype, go for early clinical trials, and make sure that, okay, your hypothesis and initial biomedical analysis is correct for the moment. And then you have, after this point, there's a huge amount of funding, especially when you are developing a proper medical product into international market. You need a crazy amount of funding. And again, in this lecture, I'm thinking about a product that you are sending globally, not in a small hospital or something like that. The product you are developing should be viable in the global scale, in North American and European market especially. So for that, you need a lot of development funding. So you have to go and find an investor who can fund that. And if it is having a patent filing ability, if it is novel idea, you can apply for the patent, go for the product design and development, and then go for engineering development. When the product is ready, trialed, and clinically proven, you can go for certification and clinical trials, which again takes a lot of months. And after everything is proven, your circuit is reliable, your clinical trial is solid, you can go for FDA filing. And when we get the FDA market, FDA go ahead, you can go for bulk scale up. That means to produce it in bulk. So ideally, this is the journey that you have to go through. That's why I say if you are going for a toy development or small funny electronic circuit, it takes months, maybe 2-3 months from idea to market. If you go to China, say if you go to Shenzhen, Guangzhou, where they do that kind of rapid developments, you can
recording in progress.
You can go from idea to market in a couple
Recording
of months.
stopped.
But if you are going for a medical electronic product development, this whole journey can take from 2 years to 7-8 years. I'm talking about the class 1 and class 2, FDA class 1 and class 2 simple products, not the class 3 high-end products where it's like a pacemaker or something, which take much longer time. Or if it is a very new concept where it was never proven, you are going as a whole new concept to the whole medical industry, that's a different thing. Again, it will take over 10 years. For simple medical electronic devices, it will take 2 to 7 years, ideally 3 to 7 years from idea to the actual market. So when we are talking about this kind of product developments, we talk about that whole journey from idea to market, which takes that amount of years, not months. So I just wanted to give you like, this is not something I want to go in deep. This is the standard process that we are following for product development. I just want to highlight that this is a FDA certified product development structure where you have to follow all the steps. Like we have to get the business requirement, we have to get the FDA doc certification requirements and do requirement specification analysis. And there's a huge amount of documentation required for this amount of work. And then we have to do hazard risk analysis and do some small amount of prototyping, prove the concept, and then go for step-by-step approach in getting it to the certifiable level. The first EV stage might be a little bigger board. It's not having all the safety features activated, but you do some amount of clinical trials, go to the TV stage, do another set of clinical trials, make sure that everything is perfect. You are in the final structure, final size, and make sure all the FDA requirements, hard hazard risk analysis requirements are fulfilled, and then go for pre-certification testing, then the certification. After you have all the certifications, you can go for FDA product certification with all the FDA documentation and everything. Then only you can get it cleared for launching in bulk. But even before that, you have another set of requirements, basic safety requirements like UL, FCC before you can go for clinical trials in US. So it's not like in Sri Lanka, of course, you can. We have to get the approval of NMRA, but it's not that hard. If you are going for US clinical trials, again, you have to go for all these, most of these certifications are given below there before you can go for clinical trials. Only after that, you can get the data and then go for FDA certification. So it takes a really long time for each and every step to get together, connect together, and launch as a product. When you are going for FDA certification, again, it will take probably the fastest I have seen is 6 months, but from 6 months to 2 years. It's a long journey. And so that was the product development. And if you go for the feasibility, so if you again, if I go back into this slide, this is a really long journey. This journey takes maybe 2 to 4, 5 years. So before you start this journey, you have to make sure that end of these 4 years, you are getting a really good product that you can market and sell and earn money. So when you are getting this idea, again, I'm going to the first slide. When you are evaluating this idea and starting, before you start going in this journey, you have to make sure within these first steps that the product is really solid one. And you can actually sell this and put it to the market and earn money, because this whole journey of 7 years and maybe requiring millions of dollars to put it into the market cannot be built on unstable foundations. You have to make sure that you have a rock solid foundation for this product development. Otherwise, so many people will lose their effort, money, time, years of their life. So that's why when we are going for this kind of medical product development, it's really different from any other development. You know, like we are using in electronic world, you are using simple Arduino boards to prototype within a day or two. All the coding is available. So it's really easy to make a prototype and functionally prove, okay, look, this works. But when you are developing a product in the medical domain, it's not that simple. So let me go to the third slide and talk a little bit about the difference in product feasibility and medical feasibility. When you are thinking about a simple product, to make it medically feasible, that means to make sure that a single person can be cured with this product, you need biomedical feasibility. That means there should be a biomedically proven technique that it should work. Say, for an example, if you have back pain, you should go for some, like back pain curing method, exercising, heat therapy, likewise. You can't expect that to cure in a totally kind of non-random, random way that's not related. So medically or biomedically, it should be having any correlation. Maybe heat to back and back pain, it might be correlated. So you have to find that correlation biomedically, and then it should be engineering feasible. That means it should be able to manufacture or prototype. When you have that too, the product is medically feasible, but it doesn't mean that it's a proper or good product. You can cure a patient probably, but it might not be feasible as a product. If your product is, your idea is not feasible as a product, there's no point working on it. The reason is you might be able to cure one or two patients with that. Maybe you can cure your relatives with this, but it might not be marketable. That means so many millions used in product development and certification, everything might go to waste if your product is not actually feasible. So we are looking at a few things that make a product feasible. One is obviously biomedical feasibility and engineering feasibility. That means it's a medically actually related way of curing or analyzing or detecting something. The other one is it should be practically, engineering wise, possible to manufacture that. Say if it is if it needs 100 kilowatts of power and wearable, you don't have a 100 kilowatt power pack which is wearable for the moment in the world. So you can't manufacture it for the moment. So if it is engineering and biomedical feasible, you have a base that can be manufactured. And then there are a large amount of things that you have to consider. Very first thing I would highlight is IP rights. Medical field is having really high margins. Maybe military and medical are the two fields which is having really crazy margins. The reason is the research and development cost and the number of years that takes for this kind of development is huge. So the people have to keep a high margin for their if investment to recover. As a result, they want to protect their IP, and there's a huge amount of patent applied and everything, especially Philips, Honeywell, these high-end guys are applying thousands of patents a year. So most probably your idea can be manufactured but cannot be sold because someone else has patented that. So the very first thing you have to do with the idea is to go for a patent search engine like Google Patent or some. There are so many of free patent engines now, and look whether there is someone or a patent which is blocking your path. If you have that block, just forget about it, because there's no way that you can go against a patent law and hide behind someone's back and sell it out loud. Chinese guys are doing it, but if you are thinking about selling it in US and Europe and making it a long-term business, that's not possible. There are so much of ways that you can bypass a patent, but that should be clearly and thoroughly analyzed by a patent lawyer, not by you. That's the first thing. And then there should be a market gap for the product that you are manufacturing. It might solve one or two guys' problems. It might solve a problem that someone in your house is having, but it might not have enough patient or enough market gap to make it a business or make it a viable product. When you are developing a medical product, it takes millions of dollars. I would say roughly 2-3 million to maybe 10 to 20 million. So your product sales should have enough market cap for that amount of sale. You have to sell 10,000, 20,000 pieces to cover your investment. So if you are catering a really rare disease, it might not have enough patients to fulfill that market cap. Another thing is, one key highlight especially is the complexity of FDA process, which means like if your product is really novel, no one ever has done it, and you apply for the patent, you get it, no one else can do it. But still, if no one has done it, FDA is not sure whether it's actually working. So FDA will ask you for so much of documentation, clinical proof and everything, which will take way longer time than a proven product. Say for an example, when we are getting the wrist-based ECG and all these medical level sensors, signals, like smartwatches had ECG and heart rate taken for so many years, but no one had proven that it's medically reliable to the medical level uh, until Apple came in. So Apple Watch had to go through so much of FDA process and years of clinical data to get to that uh, medically proven level. But once Apple has done it, anyone else can now really easily enter the market and say, look, I have a watch, which is almost like Apple Watch. This is the specification. This is the Apple specification. My one is better. So let me have this certification. It's really easy. So you have to make sure that your company, your financial feasibility, your timeline is okay with the complexity of the FDA process that you are going to apply for. If it is something that you have never done before, if it is a really new process, and if your company is small, company needs money quickly, then that's not the good product for you. You can just apply for patent and sell it to Philips or something, but you can't develop it if it is a really novel idea, which is not clinical proven for the moment. And then again, obviously available funding, it takes millions, and now I'm quite sure that none of you is having a liquid cash of millions. So it's better to get a good funding from someone when you're going on this journey. One of the biggest mistakes people do is to start the journey without correct funding, thinking that, okay, look, I can complete this whole process with $200,000, $300,000, which you can't. And when actually the truth hit the uh, 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 truth hits you, you will see that, okay, you can't raise more money because you might have few investors. You have already said, okay, look, this will take only $200,000, and you have given 50% of your company shares to that guy, and he doesn't have any money, and you don't have any other shares for raising more funding. So your whole idea will go in the bucket. So you have to make sure that you calculate properly what the funding required, and you have access for that kind of people. Like if you have never gone abroad, you have not having any connection with this kind of set of people, you only know a few guys who can spend maybe 100,000 rupees or some, like maybe 20 million rupees. You are not in a position to build that product. And then there's something called license to play. We call it, it's an industrial term. It says, why are you better than others in developing this product? If you don't have any qualifications, you don't have medical background, you don't have engineering background, you just have an idea, but you don't have money, it's just an idea, you might not be the suitable person to build this one, because you don't have connections, you don't have funding, you don't have nothing. You just have a nice idea, but it's not your position to do it for the moment. Because if you try to do it without any of these qualifications, you will fail and your product will fail. So you have to make sure that you are getting a challenge that would match your qualifications, requirements, and capability. And again, then you have to have a timeline available. Say you are thinking, look, I have another 2 years after the degree, then I want to go abroad. And within these 2 years, I'm going to develop a product and put it in the market. That's not a realistic expectation. So you have to make sure that you have 4 or 5 years of timeline available before it hits the market. And to grow it again, you have another 4 or 5 years. Then you can sell it at a huge margin to the whole company or something. But you have to have that timeline available. And then you have to go for future market trends. You have to know where the market is heading. For an example, one I can say is like 4 or 5 years back, those sleeping assistance devices, they were a huge hit. In all the exhibitions in 2016, 17, 18 time, those sleep assistant devices also big hit. Everyone knows developing sleep assistant devices, but now that device market is dying. No one else is buying those devices. People are not interested in having this kind of thing when they are sleeping. So that market is dying. So you have to make sure that you are not going for a dying market. There are so much of predictions. You can purchase these predictions at a comparative lower price and see where the market is going. And then we have to go for the competitive landscape. Who else is in the market? Say, for an example, if Philips is in the market, they are having exact same product. You are going for that product. Uh, it's almost same product. You are thinking, look, Philips is selling it at $200. I can sell it at $100. That might not be a good idea. The reason is they have much more marketing power and funding to uh, 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 make sure that you are not going up in the market. So competitive landscape is really important. Also, you have to make sure that marketing, sales, distribution, after-sale network is either available with you or you can build this network. Again, you have to have domain knowledge in product development, marketing, business development, business analysis, manufacturing, everything. If you are building this one, no single person can have all these knowledge. So, but it's a matter of either having connections or having either a fair amount of knowledge and ability to hire the good people, correct people to this higher requirement. And then you have to have the full-time resources to complete this NPI cycle, or you have to have funding available for this cycle, because you have to make sure like either you are getting very early funding, we call seed funding, or you have to make sure that you have enough funding until you go for prototyping stage or until you go for EV or DV stages and then get an investment. So that plan should be properly there and you have to have the resources. Again, the last part is global politics, how your business model will match to the global politics, whether you can manufacture this product and sell it in US and Europe, or are they keep thinking it as a strategic domain? So you need to say move your manufacturing to Europe or US to make sure that the product can be sellable. Likewise, there are so much of different aspects that you have to consider when you are building the product. It's not the product itself, obviously, and those different aspects are not engineering. It's in a domain which is way more business related than product related, engineering related, or medical related. The thing is, if you don't consider them and just present a simple proposal saying, look, this is a nice medical device, you can do this one with this likewise, it's good for presentation, but it won't help anybody with anything because it cannot be manufactured, it cannot be marketed, maybe it's too far in the future. So your effort and everyone's effort will be in vain. The better way to do is to make sure that you at least check partially on these different aspects and make sure this is a viable product, not as medically, but as a business and product wise. It's a hard domain. I know, like the normal education that you are receiving is not for this kinds of business development. That's mainly taught in business analysis degrees or business development degrees likewise. But you have to have a good idea about all these aspects. Otherwise, the decisions you are getting at this point in selecting a project may not be the correct one. There are more than enough resources in the market, in YouTube and everywhere, that you can learn these things. I think it's better that you learn at least a little bit about the product development and business analysis. These two are really critical in making sure that your product is a viable product. And if we go to the next slide, about how to gauge the viability of the product. That means if you talk about, we can gauge the feasibility of the product in product domain and business domain, thinking like a business and thinking like a product. So if you think about like a product, then one is, as I mentioned in previous slide, you have to make sure all these feasibility factors are properly evaluated in detail and make sure you miss nothing. Like the result of missing a single detail might be that you miss that detail, you are going ahead with the product development, you spent maybe 2 years of your time and many millions, and finally you missed the proper patent analysis and you missed a single patent. Now you can't sell it anywhere, and the whole 2 million, $3 million you spent on this product development is in vain because you are cut off totally. So you can't have unlimited resources at this point, but at least up to a satisfiable standard. And some factors might not be good. If I go back into the previous slide, sorry, say say you have a really nice idea, but the complexity of the process might be a little harder. They have products, but not exactly like you want. So you might need a bit of clinical trial. So it's not red, it's not green, it's amber. It might be okay. Like having 1 or 2 amber points might be okay as long as all the other points are really good. So you can compromise on it. But if you have something red, like IP analysis is red because someone has patented that, that's a no-go. And if you have that as red, you can't move forward. And if the complexity of FDA process is red, that means it's a really complex FDA application. You will need 5 years of clinical trials to prove this concept. Don't go there. Likewise, you have to make sure that red flags are not available. You can have 1 or 2 amber flags, but no red flags in all the aspects. And you have to make sure most of the sectors are positive and promising. I mean, sectors that I explained before. And again, one key thing is to use a business analysis expertise. Business analysis is a different thing. They teach it in universities and they have their own techniques for analyzing, comparing all these things, finding resources, finding export details, market growth details, and everything to compare whether this is a correct process. And it's not part of medical student or engineering students curriculum to know in deep about business analysis. So if you want to learn it from the beginning, it will take a year at least. So it's better if you can find someone who has done all these subjects or have a previous experience about it, and then get 1 or 2 hours of his time to make sure that your proposal is okay, you didn't miss anything. I'm talking about your current assignments and proposals that you are going to present. But in actual situation, you have to have a lot more about business analysis. For an example, in my company, to develop a medical product, I'm in the middle of this business analysis. So I have a head of business analysis, 2 biomedical engineering trainees from Mr. Kosala working on this business analysis. 1 business analysis undergraduate, and a very senior business analysis consultant working maybe 20% of her time helping us. So that team is needed for proper business analysis to make sure that we are not failing before the launch happens. So it's a huge chunk of work if you are doing it commercially. But even when you are doing it as part of your assignments or presentations or your degree program, that's the essential part. Make sure that you have a good business analysis for your product. And if your product concept might be really good, what normally happens is when you get the concept, you think, okay, that's a great one. No one has done it before. No one has that in the market. But if you have that thing, so many people's lives can be changed. So let's do it. But you have to remember something. It may not be in the market for a reason. Like if that's very obvious as a biomedical analysis or is obvious as an engineering product, if it is not still in the market, there might be a reason. It might be that it's too risky to do it. It might be that it's too expensive. There's not a market gap. Something is wrong. So it might be that no one has thought about it. But if it's a very obvious product and not available in the market, it might be because there's some huge problem, huge red flag, which doesn't allow that to come to the market. It doesn't mean that you can't do it. Those red flags might be changed by now. Maybe it needs a huge amount of processing power, which was not available 5 years back. But now you have that processing power. It might be that reason. But it's a red flag that you have an obvious concept, but it is not in the market. Maybe because it's not viable. And also another concept is in medical, incremental gain products are the successful ones, not the disruptive ones. When you have a huge disruptive product, you get apply for the patent, no one else can manufacture. That's a game-changing one, like a universal cure for cancer. Those products don't come to the market and become successful very often. The reason I'm not talking about the drugs. There are no vaccines, drugs, oral ones that come to the market as disruptive products and become successful. I'm talking about electronic products or maybe non-electronic, but the products that you can sell. Those are really hard to become disruptive products. The reason is, one is it's disruptive because no one else has done it before, maybe because of some reason, not because no one thought about it before, but because that product is hard to manufacture and hard to sell. The other one is, even if it is good, viable now, when you put it to the market, FDA will have a huge fuss on it, and you have to have a huge amount of money, time, and effort for proving that your concept works in this disruptive product. But for people like but we have in Sri Lanka, we don't have a big industry in these electronic product developments for medical. For our environment, best is to have incremental gain products where the concept is already proven. There are FDA certified products available in the market, and everyone is using that. There's no big risk involved for the patients. So it's a nice product, but you add something incremental. For an example, okay, look, it's a ECG, where ECG monitoring device. ECG monitoring devices are available for so many years, well proven. It's easy to get FDA because in FD, when you are getting the certificate, you can say, look, that guy is having ECG monitor. My circuit performance is like this. It's better than that guy's one. Then give me FDA. They will happily offer because you have proven that already certified FDA product is lesser of quality than your one. But you might add incremental gains. You might have data communication with the doctor to show in his screen how the patient's ECG is working, or you might have a little bit of predictions, not drastic ones, but a small amount of predictions that help doctor to diagnose. But if it is the same product that uses AI to diagnose your illness and give an alarm to the person when he's having a heart attack, when he's going to have a heart attack, that's a disruptive product. And that AI engine and those predictions will have crazy amount of work in FDA to be certified. The reason is, if that doesn't work perfectly, the patient is relying on this AI engine for predicting. It might miss that, and the patient will actually have a heart attack and die. For that reason, for that safety reason, FDA makes sure that you are going through all these years of testing with 10,000s of patients to make sure that it works perfectly. And that's not a journey you want to go through. And when you are presenting, you make sure that it's an incremental gain product if it wants to be feasible in the short term. And then one bigger mistake every one of us do is the personal bias. It's like if you have personal bias towards something, it might be extremely dangerous for the success of the product. For an example, you are a runner, you have personal bias in running, and you have a problem in the left leg, left knee. Because of that, you think, okay, if I make a product that helps runners in their left, in their knees, that will be huge successful because even I have a demand. But that demand might not be available to make it a viable product. And no one else might be as enthusiastic as you in wearing that kind of product. So if you have a personal bias to that, if you or your someone in your family has that problem, make sure you are extremely cautious in going forward with that. Because normally each and every decision you are trying unconsciously to push that product to the market, which might not be the good product in the market. So the personal biases is one of the key reasons that product fail. That's looking at a product perspective, not as a business perspective, to make sure that this product is viable in the market. And looking at a business, thinking like a businessman, that's a totally different thing. A product will not be successful on its own. It's always a business because when uh, you can be a researcher. You can be a researcher, put up some prototype, put it to some people, do clinical trials, and publish a nice paper. That's a different thing. I'm talking about a viable product that makes money. And when you are developing a viable product that makes money, it always has a business model and a business behind it. It can be something like that you develop that to some extent, get the FD certification, sell that to Philips. That's maybe your business model. It may be that you are thinking about your own business, develop that, put it in the Kickstarter, find out some money and sell it in Kickstarter first, then put it in Amazon and thinking about continuously selling it for the foreseeable future. That may be another business, but doesn't matter what that model is. You have a business, you need people to run that, you need money to run that, and you need effort and time to run that. And without thinking like a business, you can't think about a nice product and get successful. So when you think about a business, you need so much of resources, money, people. So I just want to highlight on the people because you know all the other things. Like if it is a business, it needs money, investor, location, everything. But people-wise, when you are in the initial phase, you have to make sure that all these resources are available to make sure that the project is going forward. It's not like a founder can do all these things, work in his home garage and manufacture and deliver a medical product. We have to be realistic. If it is a simple product in like a webcam, a nice small IoT device, a toy, you can build in the garage. You can send it to China, get the prototype and put it in eBay and sell it and make it a business. I'm totally with that. That's viable. But if it's a medical product, you simply cannot do it. So if it is a business, you have to make sure that people are involved. Say in the initial phase, you need biomedical engineering person to make sure that the biomedical part of it is correct. And you have to have a really good doctor who can understand about patients, therapies, everything related to this product. And then a business analysis team to make sure that you are going for the correct business. And if you are thinking about the actual product which takes a few millions to manufacture, the business analyst team actually should have 4 or 5 guys working full time and maybe a really good consultant to make sure that you uh, get every insight to make the product successful. And then you need basic product development expertise, electronic expertise, firmware, software, app, backend, all these expertise to make sure that you physically and virtually build that product. That's the initial phase. And when you go for product implementation, after our initial clinical trials are done, we are quite sure that this actually works. Now you want to go for the product development certification and testing. Then you need a totally different set of people. You need all these other people, but now you don't need much of business analysis. You can dismantle that business analyst team and put them into marketing or something. But you need a bit of those resources. And then you need totally different set of people. Like you need a CEO for your company to make sure that he's running all business management, business development, talk to the finance guys, supervise everyone, and talk to the potential buyers like Philips, Honeywell, who might buy your product, and talk to your investors, go to the seminars and talk with them, get networking. And then you need really good financial expertise, or CFO, Chief Finance Officer, to make sure that your business is running as a proper company. And then you need Chief Marketing Officer and marketing team to make sure that your product is properly marketed. The idea is, we normally think that we market the product after we manufacture and it's ready to market. It doesn't work. If you want your product to be marketed, you have to start at least 1 or 2 years before your product is ready to the market. You have to build a presence in the market space. You have to go for exhibitions, talk with people, put up a landing page, which is a website, and draw the traffic there, and have a Facebook page and post related post everywhere, and build the awareness. So when you launch, there will be 1,000, 2,000 people who are ready to buy it outright. Without that, you can't start that momentum. Without that momentum, which will build for the 1 or 2 years from before, without that, you can't sell. So you have to have a marketing expert for a really long time. And then you have to have manufacturing, logistic expertise, a chief operating officer who is taking care of all the operations and everything. So it's a large operation. If you already have a company which is manufacturing medical devices, that's a different thing. But if it is a new business, if it is a new proposal, if it's a new idea, you have to think through all these. So to make it a viable proposal, to make it worthwhile for an investor to invest on this proposal, you have to think about all these things. It's not the medical product itself. You have to think through, as a business, as a successful product, as the team you need, as the finance you need, as the IP and all the other different factors you need to fulfill to make it success. So all these things should come together in the proposal stage. Without that, if you present just the product idea, the person who is looking at that idea has to either do all these things or think, okay, look, that's a nice idea, but I will think about it later. So if you are actually thinking about seriously putting that idea into market and present it in a viable manner, you have to think through all these things. The presentation shouldn't be a large jargon of medical stuff and everything. It should be there, but it can be only 20% of the whole presentation or whole what you have done. It's just to make sure that, okay, look, that works medically. That's it. But the whole product, whole business idea, whole success story is way more than that. So so for an example, if you're pitching something, just to give an example, you can say, look, this is my idea. I have a product which is a wristband device. It will measure your heart rate and ECG and blood glucose level and warn you about a possible heart attack coming on. And then you have to talk about all this other stuff. It was proven. I did a prototype, and this is the biomedical analysis, which says that you have 10 research papers that says, look, it can be done. And I have done a small prototype. It works. And it will need at least 6 years of time, because this is never done. We are thinking that FDA will take 2 years for the certification. We will need 1 year for concept development, and then 1 year for converting that to actually prototype, and probably 1 to 1.5 years for clinical trial and certification. And then we can go for FDA for another 2 years to get the certification. Altogether, 5.5 years for building up. And it will take, for all these timelines, it will take 2.5 million. Within the first year, you need 200,000. Second year, 500,000. Likewise, you can present that timeline versus finance needed. And we have done the market analysis. That market analysis says, okay, look, this domain is 5 billion large, and no one is in the market. But these guys, Philips, and all these guys are in the research. They have done this kind of research and IP analysis. But we see that in the IP scope, we have a hole where we can apply for the IP. and we are quite certain that it will get that IP. And we have done the requirement analysis and everything. So this is the analysis. We are green on these aspects and amber on these aspects. But these ambers are okay considering that we have green on these things. So your pitch should be something like that. It's not, on my personal opinion, if you have only saying, look, wearing this watch and getting the ECG and heart rate monitoring and oxygen saturation and predicting something, it's a nice idea, of course, but it doesn't mean that it's a viable product that someone can get it and run and implement. So again, to summarize what I have mentioned so far, a business idea or product idea should be looked at all angles. And finally, to make it successful and to make sure that people are benefiting out of it, it should be profitably sold in the open market. That's the only way that people can actually buy and use that. To make it profitably in the actual market, you have to make sure that whole thing is satisfied. You have thought through the whole journey. You know all the different aspects of it, and that all these boxes are ticked properly. So that's what I want to share. I'm happy that if you get anything out of the lecture, just let me know. Any comments you have, any questions, I'm happy to answer them. And my expectation for this one is to make sure that when you are presenting the ideas, presenting business models, and one day when you are building your business on medical device, use these things. Don't go only in engineering or biomedical analysis. There are so much of other things to think about when you are developing a medical product. So there's a question whether the slides can be shared. I can share it after the lecture.
Okay, sir. Thank you, sir. So there are some questions asked from you on a Slido. Shall I read them out?
Yeah, please.
So is there any particular platforms for applying fundings in Sri Lanka?
There are not an online platform, but there are a few places that can help you. Trace has good set of companies. Trace, which is the Trace City you have in what you call Maradana. Trace City has a nice set of investors, and there are set of angel investors who are happy to invest, but it's a little hard to find. Like, they are isolated. I don't see a single individual platform where the investors and inventors come together. There's something called Inventors Commission, but it's not mainly focused in medical. It's mostly on general devices, general products, not in medical.
Yes. Okay, so thank you, sir. Sir, can you also tell a bit more about the FDA classes?
Yeah, FDA class, one is FDA exempted, which means your device is simple massage or something. You can say, notify FDA saying, look, I am selling a product like that. It's not FDA. But if someone has a query, this is my contact number. So you log in FDA. So it's the FDA says, okay, this is a simple product. You are not claiming anything hard. So just go and sell. If there's some problem, we'll contact you. That's FDA exempted. And FDA class 1 application is a simple devices with lower risk, lower claims. So it's very basic, like something like massages for pain relief. So it's simple, not very. It doesn't say, okay, massager for fully curing varicose. That's a different thing. If it's the same massager is said to cure varicose, it's a surely FDA class 2 device, because it's complex and you are citing something definite, curing device. Or if it is risky, if it is a heating therapy device, heating can actually burn you. Then the risk is higher. So then that's a FDA class 2 device. But if it is simple massager for pain relief, it might be FDA class 1. That actually evaluates what you are claiming and your risk. Based on that, either it can be FDA exempted, FDA class 1, or FDA class 2. And if it is a really critical device or a drug or injection, that's definitely FDA class 3, which means it's life-threatening if it was used wrongly, or if you don't, if you use it in an allergic person or something like that. So that goes to FDA class 3. Like in electronics, more common example is pacemaker, like which is worn inside your body for regulating the heart rate. Because if that device fails, you will immediately die. Then it's a FDA class 3 device. I can design only up to FDA class 2. I have never done FDA class 3 electronic device.
Okay. So thank you, sir.
No.
Sir, there is another question whether just after our university, whether to go into business or should we have some experience on the business field and go into.
Depends.
Yeah.
Normally, globally, when you talk about global statistics, the businesses that were started after 40 years are more successful. Success rate of that is much higher. But again, when you are at early stage into a 23s, 24s, you can afford to be more unsuccessful. It can be simple experience. You run your business for 3-4 years, get a good investment from someone, run that. If it is not successful, just forget about it. You got a really good experience. That's it. So if you are thinking about experience, you can start right now. But if you are thinking about definitely really high-end, reliable business, it might be advantageous to go to industry, get some experience, and start. If your only requirement is to be successful, not the experience, starting late is better.
Yeah.